some point in this question, we're going to need to find all the factors of 2022, or at least the prime factors. So I think it's actually a good idea to do it right at the start. And a good shout is to go with 2, and then it's going to be 1011. Now the digits of this number add to a multiple of 3, which means that 3 will go into it. That is a fact well worth learning. 3's into 10, go 3, remainder 1. 3's into 11, go 3, remainder 2. It's going to be 337. Question is, does anything go into 337? And actually, if you're doing the senior maths challenge in the year 2022, it's always worth finding the prime factorization of 2022, like checking it with a calculator beforehand, because then you know when you're ready to go about solving this. Because otherwise, it's going to be quite time consuming. I mean, we can see that 2 doesn't go into it. The digits don't add to a multiple of 3, so 3 isn't, 5 isn't. But we don't know about 7 or 11 or 13 or anything like that. It turns out that actually, I'm not going to show you that it is prime, but it is prime. So we're actually sorted. So I can write down 2022 is equal to 2 times 3 times 337. Now we might want to think about the different factors. Like we're going to get 6 as a factor, and we've already got 1011, what other ones? But right, really, we need to just focus maybe on trying something out. Maybe because is there more than one option, or is there like one, does it have to be a certain number? So if I tried 6 and 337, right, at this point, we can sort of see now, actually, n has to go into this number here and into this number here. So there's no combination I can make that would work except for one. See, if I try 2 and that, right, 2, there's no number that goes into both of these except the number 1. And that ends up being the answer. And that might be something that you think about right at the start, the fact that actually this n has to go into both of these numbers, but in fact we have 3 distinct primes multiplied together, so there is no number except 1. That's it.